Getting close to the end. We'll see if we can make it this last video. Differentiate each of the following. Always simplify original functions. You don't know how to do this problem yet. Right here, this is a composition. X squared plus 2 inside the function of raising something to the negative 1. You don't know how to do this yet. But we can simplify the original problem to this. And that makes an easier problem. I've gotten rid of that exponent of negative 1. And so now it's just a quotient rule. So I will just apply the quotient rule. Plain denominator, derivative of the numerator, minus plain numerator, derivative of the denominator, all over the plain denominator squared. Quotient rule. But the real point to this one was that simplification first. And even if I knew how to handle that one factor there, I would still do this. So plain denominator, derivative numerator, plain numerator, derivative denominator, plain denominator squared. Now let's clean that up a little bit so it looks a little bit better. So now actually taking the derivatives. So that's going to be x squared plus 2 times 1. Derivative of x is 1, derivative of 1 is 0. Minus plain numerator, so don't do anything. Derivative of x squared is 2. Derivative of 2 is 0, so I don't need that. All over x squared plus 2, quantity squared. There's my unsimplified derivative. Simplifying, so that's going to be x squared plus 2 minus the quantity, 2x squared plus 2x. Just multiplying out the denominator. Notice I didn't cancel anything. Nothing cancels initially, 99% of the time. When I distribute that minus sign and combine like terms, I'm going to get negative x squared minus 2x squared, negative x squared. I'll still have that plus 2 and minus 2x all over x squared plus 2 quantity squared. And there's no reason to really multiply out the denominator. You can multiply out the denominator if you want. No one does it. So just leave it alone. And there we did it with the quotient rule. Okay, last quotient rule problem. Or not quite the last quotient rule problem. Next one's going to be a quotient rule problem. Or the last problem on the section will be a quotient rule. But this is too a quotient rule problem. And again, one of the points here, simplify first. That what I want to do here is multiply this out. If you didn't, you'd have to use a quotient rule and a product rule. And we want to avoid two rule problems as much as we can. So multiplying this out, just foiling that out, that's going to be x cubed. I just lost my train of thought. Plus 2x squared, there we go, minus x squared plus 2x, just foiling out that denominator. And that's 4 over x cubed plus x squared plus 2x. Always simplify original functions if you can. And so we've got x cubed plus 2x squared minus x squared minus 2x. There's a sign error there. Minus 2x, which will give me x cubed plus x squared minus 2x. And now I'm going to use quotient rule. So plain denominator, derivative of the numerator, minus plain numerator, derivative of the denominator, all over the denominator squared. Plain denominator, derivative of numerator, plain numerator, derivative denominator, plain denominator squared. You do not have to show that step. That is an optional step. I just show it until I think everyone knows the product rule or quotient rule. Okay, actually doing the derivatives now. Plain denominator. So I leave that alone. Derivative numerator. 0 times 0. Actually writing the 0 down. Good number of you are just not going to write the 0 down at all. And that will be wrong. And then you're thinking, well, why would it be wrong just to skip that 0? We've done it before. And we did it up here. When we were differentiating this one right here, derivative x was 1, derivative 1, 0. We didn't write it down. And then we did it again right here. Derivative x squared is 2x. Derivative 2, 0. We didn't write it down. That we didn't write down that this was really 1 plus 0 and this was really 2x plus 0. I didn't have to write the zeros down here. Again, that technically the derivative here, derivative x plus 1 would technically be 1 plus 0. And the derivative x squared plus 2 would technically be 2x plus 0. I didn't write the plus zeros because they were plus. And if they'd been minus, I wouldn't have to write them either. Plus 0 minus 0 doesn't change the game, doesn't add or subtract anything. Here, it's times 0. And so the 0 is hugely important here. Times 0 changes everything. And so you got to be really careful when one of these derivatives is 0. If it's adding or subtracting 0, yeah, drop it. But if it's times 0, we need it. And heaven forbid if it's ever divided by 0. Divided by 0 is undefined. So the point, one of the major points of this problem is that 0 there is playing a very significant role. I need it. So we were doing this first part here, plain denominator, derivative of the numerator, minus plain numerator, derivative of the denominator, 3x squared, plus 2x minus 2, all over x cubed plus x squared minus 2x, quantity squared. And there's my unsimplified derivative. Simplifying, since I'm multiplying 0, all of that first term is 0. Then distributing that 4, or negative 4, that's going to be minus 12x squared minus 8x plus 8 all over x cubed plus x squared minus 2x quantity squared for negative 12x squared minus 8x plus 8 all over x cubed plus x squared minus 2x times 2. And there's my simplified derivative. Okay. Finally, to the last problem in this section. Suppose u of x and v of x are differentiable functions of x, and that u of 2 equals 3, v of 2 equals 4, u prime of 2 equals negative 8, v prime of 2 equals 6. So we've been given some information about two functions, u and v, and then some specific values of what's going on at 2. Then it says, let f of x equal u of x over v of x. Find the equation of the tangent line at x equal 2. Okay, equation of the tangent line. We need a slope. And the slope is going to be f prime of 2. So that means I got to find f prime, plug in x equal 2. Well, f prime of x is going to be the derivative of u of x over v of x. That's all we know about f, is what it is. And so all I can do here is just write down the quotient rule. Formula. That's all I can do here. because I don't know what u and v really are. So just writing down the quotient rule formula, plain denominator, that's not the denominator though, plain denominator, derivative of the numerator, minus plain numerator, derivative of the denominator, all over the plain denominator squared. Quotient rule formula. Then the slope specifically was f prime of 2, so plug 2's into all those. So all I could do to start was say I need a derivative, but I didn't actually have any formulas, so all I could any rules, so all I could do was write down what the basic quotient rule says. And then I was supposed to plug in 2, so I plugged in 2, but then they gave me all of those values. V of 2 is 4. U prime of 2 is -8. U of 2 is 3. V prime of 2 is 6. V of 2 is 4. So then I can use the values they gave me. And so I have -32 minus 18 over 16, which what is -50 over 16, divide by 2, -25/8. And there's my slope. We need the point. At x equal 2. Well, if x equals 2, then y equals f of 2. We always get y coordinates from plugging into the original function. But all I know about f is that it's u of 2 over all I know about f is it's u over v. So in this case, u of 2 over v of 2. And can we get it all on one screen? Yeah, u of 2 was 3. V of 2 was 4. And so the point is 2 3/4. And so now I can answer the actual question. The equation of the tangent line just going into point slope is going to be y minus 3/4 equals -25/8 times x minus 2. Now, like I said, quiz or test time, I don't care how you leave the answer, but if you wanted to make this answer look prettier, I could distribute, and so that's going to be plus, and the 2 and the 8 are going to cancel, leaving 4. So I'll have 25/4. Then add the 3/4 to both sides, and I get y equals -25/8x plus 28/4. And then you could call the 28/4 14/2, you know, whatever you wanted to do. But the point on this one is it just was kind of logic. I had u over v, so all I could do was write down the formula for the derivative, the quotient rule, plug in my 2's, that gave me the slope, and then the same thing for the point. And that concludes this section.